make sure you number it. We are going to start by plotting the points. So it says, for example, 1, we're going to determine the location of trapezoid WXYZ after translating it 3 to the left and 5 up. And then we're going to also reflect it across a specific line. And the line we're going to use for this problem is y equals x. And we're given the original coordinate points. So whenever you're doing this by yourselves, you do not need to like write out the coordinate points, but since it's notes, we're going to do that. So take a second and use your pencil. We're going to plot the original points, and we should have a cute little baby trapezoid. So take a minute, plot your points. W's at -4, 6. X is at -2, 6. Y is at -1, 4. And Z is at -5, +4, 1, 2, 3, 4. So plot your points. And a cute little baby trapezoid. So once you have your original, it says the first thing we're going to do is translate to the left 3. And then it says up 5. But if you actually look, we can't go up 5. So we're actually going to change this number to, instead of a 5, we're going to change it to a 4. Just because I made this and it didn't fit. So my bad. But we're going to go to the left 3 and we're going to go up 4. So take your original trapezoid and we're going to kind of count to the left 3, up 4. This one, you should be able to recognize the rule. You don't really need to remember the rule because you can literally just take your coordinate points and count. So we're going to take W, we're going to count to the left 3. We're going to go up 4, just like we did last week. 1, 2, 3, 1, 2, 3, 4. And that's why we had to change it to 4 and not 5, because it wouldn't fit on our graph if it was 5. So take all your coordinate points and shift left 3, up 4. So when we're going to the left 3 and up 4, if we were to write a rule or pick a rule that would represent it, because this is how on your EOC they like to put these types of problems, they're not really going to have you graph and plot points on the EOC, but you'll have to pick what rule was done to get from W to W prime. So if I'm going to the left 3, should I say X plus 3 or minus 3? Minus. So I'm going to say X minus 3. And then I have Y, I went up 4, so should I say Y plus 4 or minus 4? Plus, because you went up. So this one was easy peasy. That's my rule. You can either literally use your rule to change your coordinate points, or you can look on your graph. Either way, W prime should end up at -7, 10. X prime should end up at -5, 10. Y prime should end up at -4, 8. And then Z prime should end up at -8, +8. So that's kind of where we stopped last week. We just kind of like did one step. Now today we're also going to do something else to the problem. So first we translated to the left 3, up 4. Now what we're going to have to do, what the second column is for, is reflect over the line Y equals X. So we're going to reflect over the line Y equals X. So Y equals X has a positive slope. So this is not one of the cute ones that we're going to be able to easily count. It's a little weird. Y equals X has both variables. So it's actually going from corner to corner of your graph through 0, 0. It's a diagonal line. It has a positive slope. This is one of the tricky ones where it's not that easy to just count to the left 5, down 5, right 5. This one you actually have to remember a rule. So if I'm reflecting over Y equals X, that's the equation of the line. Does anybody happen to remember the rule for it? Yes. So this is the one that you should definitely remember. All it's doing, if it's a diagonal line, either positive or negative, you should remember the rules. I'm going to make a poster around the room. But all it does is flip the coordinate point. Because it's a positive line, all it does is flip the coordinate point exactly the way it was. So my rule, my X and Y change to Y, comma, X. So I'm not going to use the original W. I'm going to use the new W I just made. So W prime was at negative 710. So all I'm doing for W double prime is switching the coordinate point. So W double prime is going to be at 10, negative 7. It is Christmas time. X W prime was at negative 510. So now it's at 10, negative 5, because I'm just switching the coordinate point. Y double prime, it was at negative 4, 8. Now it's going to be at 8, negative 4. So I'm just flipping it. And then once you have it all flipped, you're going to plot your new points. So this one is kind of hard. You can't just like, I mean, some of you can eyeball where it's going to go, but it'll be a little difficult. So the reason why we cannot just like count to the left and count to the right is because now it looks like it almost like rotated. It's sideways because the line is diagonal, so it's turning the picture as well. Okay, so once you get done with number 1, set up number 2. You're going to start by plotting your original points. And this one's a triangle. It says ABC has vertices A 1, 2, B 4, 6, C 6, 1. We're going to figure out where it is after reflecting over the y-axis, and then we're going to translate it. So this should be an easy problem overall, but we're going to have to reflect first. So plot your point. Okay, so it looks like most people have their points plotted for number 2, the original. So the first thing we're gonna have to do, it says we have vertices, blah, 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 determine blah, 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 blah. After reflection over the y-axis. So I have to reflect it first this time. So I'm going to reflect it over the y-axis. And then the second part, then I'll translate it, which is the easier one, translate to the right 6 and down 7. So first we're going to do the reflection specifically over the y-axis. So you're going to take your highlighter and we're going to highlight the y-axis. So this one's a nice one. We like this one on Friday. This is the one where we just figure out how many to the right the point is, and then we go the opposite direction to the left. If it was above the x-axis, we would count up, and then we would go that same amount down. So in this case, if I look at, I don't know, A, from the line of reflection, how many to the right is point A? 1. So now I'm instead going to the left 1, and A prime will be to the left 1. And I'll kind of zoom in for this part. We're going to do the same thing with B and C. So if I look for B, if I'm talking about my line of reflection and I'm going to the right 1, 2, 3, 4, now I'm going to go to the left 4 for B prime. And I'm going to do the same thing with C. C is 6 to the right. So now I'm going to go 6 to the left. Yes, that's all you're doing is literally going the opposite direction the same. And then there's no need to remember the rule for this one necessarily. We're gonna write the coordinate points and then we'll figure out what the rule is because you probably don't remember it. So A prime is at -1, 2. B prime is at -4, 6. C prime is at -6, 1. So if I'm looking at the original coordinate point to the new coordinate point I just created, what changed? The x turns negative. So the rule for this is just -x, y. And remember, technically, whenever the variable in the rule is negative, that all it means is it's flipping its sign. So if it was already negative, it turns positive. If it was positive, it turns negative. So it doesn't mean it has to be negative. It just changes the sign. So x flips its sign, y stays exactly the same. So the second transformation, we're going to take our triangle we just made, and now we're going to translate it to the right 6 and down 7. This is same thing. We don't need to remember the rule for this. We're going to literally take our new triangle. We're going to go to the 6 right and then down 7 for every single coordinate point. So A double prime should end up at 5, -5. B double prime should end up at 2, -1. C double prime should be at 0, -6. So notice the shape is not changing literally at all. It's preserving all the angle measures on the inside of the triangle. It's literally not doing anything. All it's doing is just like flipping it around and rotating it. But it looks like it's the same size. It's just like in a different order. So the rule for this, if I go to the right 6 and I go down 7, what I'm doing is x plus 6 technically, and then y minus 7. How do we feel so far? Not too bad. We're going to skip the third one, so you can scribble it out if you want. We're going to go straight to example 4, which is on the back side. So example 4 on the back side, what's up? Yeah, it's best. So on the back side, example 4, take a second. We're going to plot the original points. We're going to skip 3 at the bottom. So on the back, we're going to plot the original points for number 4. Oh, and it's upside down. This is a parallelogram. Doesn't it look like a diamond or rhombus? So plot your original points, I, J, K, and L. Okay, so Your original coordinate points look like that. So the diamond, little sideways, little parallelogram, rhombus. The first thing that we're going to do is we have to, says it's reflected over the line y equals negative x. So last time it was positive x. This time it's negative x. We have both variables. So what is this line going to look like? Yes, it's going to go down from left to right because it has a negative slope. It's still going completely across my graph. It's going from the top left corner to the bottom right corner. It's still passing through 0, 0. It's not a Q1. It's not perfectly vertical or horizontal. It's ugly. It is what it is, but it's negative. So this graph is sad. It's going down. This is the ones that I think you should remember the rules for. There's only really two. If it's y equals negative x, does anybody remember what happens to the coordinate point? Perfect. So they're going to flip and they change their sign. So technically the rule is going to be, so the equation is y equals negative x. So the rule is negative y comma negative x. So what you're doing is you're flipping the coordinate point and you're changing the sign. If it was negative, now it's positive. If it's positive, now it's negative. People see the negative and they're like, that means it has to be negative. But if it's already negative and you're adding a negative, two negatives make a positive. So think about it as flipping and switching the sign. So I was -2, -2. If I flip it and I switch the sign, what's it going to be? +2, +2. J prime, I'm going to flip it and I'm going to switch the sign. So what's it going to be? 2 and 5. K prime, if I flip it and switch it, 5, 0. And then L prime, flip it and switch it. 5, 3. So take a minute, plot your points. Those are the only two rules, really. I think you might need to write the points out and actually physically change the points. The rest you could probably do without showing any work at all. And then the second part of the problem, we're going to translate it 5 right and up 5. So it's going to the right 5 and it's going to go up 5. So this rule is going to be x plus 5, y plus 5, because we're going to the right and we're going up. So it's easy peasy. So you can either use the rule to find the new points, or you can literally count it the right 5, up 5, whatever you prefer. Most people like to just physically count 5 and 5. Oh. 1, 2, 3. How do we feel? That's bad. The hardest part is going to be if you have an equation, y equals negative x or y equals x. The rest of it should not be too bad. There's 4 problems at the bottom. You don't really need to write out the coordinate points. If you don't want to, you can just show both transformations, and that's it for today. Okay?